So the AI boom is here, and it's happening way, way faster than anyone ever predicted. But hiding just beneath the surface of all this incredible progress is a massive, and I mean massive, problem. It's a challenge so big it could literally stop this entire revolution dead in its tracks. And the solution? Well, it might just be the most insane industrial project in all of human history.
Okay, let's just dive right in. We spend all this time talking about algorithms and data and who has the best chips. But what if the real wall we're about to hit, the absolute hard limit to creating more intelligence, is just having enough juice to keep the lights on? To give you a sense of the scale we're talking about, by 2030, just the next generation of AI chips are projected to need 200 gigawatts of power. Now, what does that even mean? Well, that's enough energy to power over 150 million homes. The entire United States power grid is just under 500 gigawatts. So we're basically talking about building an electrical grid almost half the size of the entire US from scratch in just a handful of years and dedicating all of it just to AI. To really get why this is such an impossible problem to solve here on Earth, we first have to understand where all that energy is actually going. And it really boils down to two key things. Now, this is where it gets really, really interesting. We hear a lot about how much energy it takes to train a big model like ChatGPT. But you know what? That's kind of like a one-off event. The real monster, the thing that never sleeps, is inference. That's every single time you ask a question, generate an image, or get a piece of code. That's the part that has to run 24/7. And folks like NVIDIA CEO expect the energy needed for inference to eventually be 100 times bigger than training. That constant, never-ending demand is what adds up to that insane 200 gigawatt problem. So here's the core issue. We have a basically infinite demand for AI, which creates a basically infinite demand for energy. But we live on a very, very finite planet. Let's take a look at why our current energy system just has no way of handling this. And this chart just says it all, doesn't it? On the left, you see that hockey stick curve of what AI needs. And on the right, that's the sad, flat line of what we can realistically build on the ground. That's not just a gap, that is a canyon. And it's not like people haven't thought of options. You'll hear, well, what about nuclear? Okay, well, to meet the demand, we'd need to build over 10,000 new nuclear power plants. It's not going to happen. Okay, what about natural gas? Even if we could magically double our output, it would be a tiny drop in the bucket, maybe 2% of what's needed. And we can't even do that. Critical parts like the big GE gas turbines already have 7-year back orders. The conclusion is pretty clear. There is nothing on the ground that can scale fast enough. So if we've basically hit the physical limits of our own planet, where do you go? This is the moment where the story takes a wild turn. We stop looking at the ground for a solution, and we start looking up. When the problem is this big, the solution has to be even bigger. You have to start thinking outside the box. Or, in this case, maybe outside the entire atmosphere. The idea is so radical, it's almost simple. If you can't get enough power on Earth, you go to where the power is literally unlimited. It's on 24/7 and it's free, the sun. And you don't just beam the power down. No, you move the entire data center, the whole shebang, up there with it. And look, before you dismiss this as some crazy science fiction plot, you should know that the big players are already working on it. Google actually spent tens of millions of dollars on a secret research project they called Suncatcher to test this exact idea. They blasted commercial AI servers with radiation to simulate space, and their conclusion was simple. Yep, it's viable. The hardware actually works up there. So how would this thing actually work? Well, the whole architecture breaks down into 3 main steps. First, you launch these huge fleets of satellites that are really just data centers wrapped in solar panels. Second, these things just soak up solar energy 24/7, no clouds, no nighttime. And third, they all talk to each other and back down to Earth using high-speed lasers, which, by the way, is technology SpaceX is already using for Starlink. This is a truly revolutionary vision for what AI and energy could be. But a vision is useless if you can't actually build it. And right now, there is only one company on this planet that has even a remote chance of pulling this off. For 60 years, getting to space was just stupidly expensive. Then SpaceX showed up with reusability and changed the game. But the really critical piece here is Starship. It doesn't just make space a little cheaper, it completely rewrites the laws of what you can even do in orbit. We are not talking about a 10 or 20% improvement, we're talking a potential 100-fold reduction in the cost to get stuff up there. It changes absolutely everything. And this is what that looks like. I mean, just look at this chart. This is not a competitive market. This is a monopoly. If you exclude China, SpaceX already launches 97% of all mass to orbit. Once Starship is fully flying, that number is probably going to be more like 99.9%. They don't just own the road to space, they are literally the only ones paving it. There's this analogy from the source material that just hits the nail on the head. It perfectly captures the difference in scale here. It's not just a better rocket, it's a totally different type of machine. One company is building a global transportation system, and everybody else is building little hobby planes. They're not even playing the same sport. And this advantage goes so much deeper. Nobody else in history has ever mass-produced any of this stuff. SpaceX mass-produces rockets, they mass-produce rocket engines, and they mass-produce satellites. And that last point is just staggering. In just a few years, they have put more satellites into orbit than every other company and country combined over the last 60 years. They have a manufacturing lead that is just completely unassailable. So let's connect the dots. If one company has a total monopoly on the only workable solution to the single biggest problem facing the biggest technological revolution in human history, what is that worth? The numbers here start to get a little hard to believe, so let's just break it down. Okay, let's start just 5 months ago. At that point, SpaceX's private valuation was already a mind-blowing $400 billion. That already put it in the league of the most valuable private companies on Earth. Now, let's fast forward to today. The company is now reportedly raising money at an $800 billion valuation. It doubled in less than 6 months. And the reason for that insane jump? The market is finally waking up to the fact that SpaceX isn't just a rocket company. It's the future of energy and AI infrastructure rolled into one. But even $800 billion is pocket change compared to the ultimate prize. The projections for the annual revenue, not valuation, annual revenue from this space-based AI and energy market are as high as $10 trillion. Just let that sink in for a second. $10 trillion every single year. And even try to put that number into perspective. $10 trillion a year is more than 10 times the revenue of the entire global oil and gas industry. We're talking about an amount of economic value that is almost unimaginable, all unlocked by moving our most important infrastructure off the planet. And that brings us to this final fascinating question. For years, this dream of becoming a multi-planetary species has been this grand vision, but it's always been looking for an economic reason to exist. Maybe this is it. Maybe AI's bottomless thirst for energy is the killer app that finally pushes humanity off-world, not just for the sake of exploration, but for our own technological survival.